Hey guys, welcome. This is our 1.7 video. Make sure we go ahead, always write the heading, 1.7, midpoint and distance in the coordinate plane. So we're talking about midpoint and distance formula, which is going to be two huge major topics and major things we're going to see all the way throughout the year. So let's go ahead and dive in. So our goal is to find the midpoint and also find the distance between 2 points. So what ways can we do that? So I want you to go ahead and make sure you write down all of this. Basically, we have two different ways to find the midpoint: if we are finding it on a number line or if we're finding within a coordinate plane. Very similar in what we do. On the coordinate plane, or sorry, on the number line, all we have to do is find the average, so basically add our 2 points together and divide by 2. It's kind of like if you took two tests and you had an 80% on one and 100% on the other. What would be your average test score? You would add them together and divide by 2. Your average test score would be 90. Okay? Looking down here in the coordinate plane, we have more than just 1 point for a coordinate. On the number line, we just have the 1 point. On a coordinate plane, we have a y and an x, so we actually find the averages of the x's and the averages of the y's. So it's a very similar formula that we would use. So x1 plus x2. So taking x1 from one of the points A and x from the point of another point B and dividing it by 2, that will give you the midpoint x value, and then you do that same thing for the y. Alright, one more vocab. Okay, and then we have this piece, so we want to take note of that. And this is the distance formula. We're going to talk more about the distance formula later in this chapter too. Or not, sorry, this chapter, but later in the book. But the distance formula is actually based on Pythagorean's theorem, which will demonstrate how this piece right here helps us actually come up with this equation. But this is our equation. What we're basically doing is distance. To find the distance between 2 points, you take the difference. How far are two things away from each other? We did this on the number line in the earlier this chapter. So to find the distance, we find how far apart are the x values, how far apart are the y values. Like we talked about before, distance can't be negative, so we go through this kind of interesting process where we square both pieces, because when you square a negative number, it comes out positive, so no matter what, you're going to have a positive value. And then we have to square root it to send it back to its original place. So this is one that we're going to have memorized. We're going to use it all the time. All right, let's get into a couple examples. Okay, first, nice easy one. We'll call this example 1. I don't know why I used that marker. Let's switch. We have -4 and 9 are my two endpoints, so what's the midpoint? So the midpoint formula is pretty simple. I just take the 2 points, whatever they are. I don't even have to have this picture, and I add them and divide by 2. So -4 plus 9 is 5. And then 5 divided by 2, we could leave it as that answer, but it looks like we kind of try and want to plot it somewhere on here. So 2 goes into 5 twice with 1 left over, so we can get 2.5. And if you go to about 2.5, that's probably about 2.5 right there. And that looks pretty close to being the middle of this. So I would say that's probably correct. Let's look at our next problem. Okay, so this one's tricky here. So the midpoint is -2, 1. And an endpoint is -5, 7. What are the coordinates? So first of all, I want to write out what is the formula. Okay, so we take the values of the x's divided by 2, and the values of the y's, add them and divide it by 2. And that's going to be your midpoint. Well, if I knew what the two endpoints are, it would be pretty simple. So I have the endpoint up here of -5, comma 7. Down here I have the midpoint though. So I don't know what's down here. So this presents a problem to me. I would love to just plug in -5 plus whatever this x value is divided by 2, and I'd get this. So what we're going to do actually is we're going to go ahead and plug in what we do know. And the midpoint we know. So instead of m, we can actually plug in what we typically would say is our answer. equals. Well, this is our x1 value and our y1 value. I don't know x2 and y2. So we got negative 5 plus x2 divided by 2. And then we have 7 plus y2 divided by 2. Okay? So again, this presents us a problem. So what we want to do is we want to go ahead and set each piece equal. So if you take a look, this negative 2 should equal whatever this is going to end up being. So whatever I need to put in x squared, or x2, needs to equal negative 2. And likewise, for 1, whatever y2 is, this needs to make sure it equals 1. So I'm going to set up two separate equations to go ahead and solve this. So I'm going to move my face for a moment. And so what we're going to have is we're going to have negative 2 set equal to negative 5, comma, not comma, sorry, that's supposed to be a plus. 1 second. Let me erase that. So negative 5 plus x2 divided by 2. So this should help me solve. So first thing I need to do is get rid of the 2 down there. So I'm going to multiply both sides by 2. Off the page. So we get negative 4 on here. Negative 5 plus x2. And then I'm going to add the 5 over. We're going to get 1 equals x2. So that's one of our coordinate points. All right. Now we got to fill in the next piece of the equation. I'm going to go ahead and flip it over to a new sheet of paper here. So you can follow with me, but we're going to do 1 equal to 7 plus y2 divided by 2. Okay. So that was 1 equals 7 plus y2 divided by 2. Multiply both sides by 2. So we're going to get 2 equals 7 plus y2. Going to subtract the 7 and we should get negative 5 equals y2. Okay, so we have our two coordinate points. I'm going to go back. So that was negative 5 equals y2. And let's see if this makes sense. 1 comma negative 5 is going to be right about there, and that seems like it would be pretty accurate. So our final answer, I'm going to put right over here, what is the endpoint? It's going to be 1 comma negative 5. Okay, I hope that problem didn't seem super long. It really isn't. I just took a little while to go through it, but we're using the formula to help us set it up. We just have to do it in a kind of different order. All right, one last one. Okay, so this will be our last problem. This is example 3. What's the distance between these 2 points? Round to the nearest tenth. So our first objective is going to be to write the formula for the distance, which is d equals the square root, and then we're going to do x2 minus x1 squared plus y2 minus y1 squared. Okay, we could write x1 minus x2 and y1 minus y2. The order really actually doesn't matter as long as we put, if we're putting the x2s in the front spot and the x1s in the back spot, or vice versa, that's the only thing that matters, so we keep that consistent. So I'm going to label these x1, y1, x2, y2. And all we have to do is go ahead and plug it in. So x2 is 4 minus x1 is a negative 7. So notice I put a negative in there. That's a part of the equation. There's a subtraction sign and the negative with the x1. And that's going to be squared. Plus y2 is negative 3 minus 5. And we are going to have to use a calculator because it's asking us to round to the nearest tenth. So don't make mistakes on adding or subtracting here. So please, if you need to use a calculator, but 2 negatives make a positive. 4 plus 7 is 11 squared. Okay, 2 negatives, so they're both going to stay negative. We're going to get a negative 8 squared. Again, since I'm squaring the negative, it's going to become positive. So 11, I know these, 121 plus 64. And then we just add those two together, and we're going to get 185, but we still have to take the square root of it. Okay? And so I'm going to take the square root of 185. What's nice is that we can just use our calculator, and we're going to get 13.6, round to the nearest tenth. That would be the first decimal spot. And there's no number after 6, so I can't round up. So there we go. That's the distance. And so it's just kind of a plug and solve. Alright guys, over and out.